question, it is given that tangents are drawn to this parabola at the extremities of chord. Then we need to figure out the angle between tangents. Okay. Actually, whenever you need to figure out the angle between tangents of parabola, please remember this extremely important concept. And the concept is, let me explain you that concept with the help of this standard parabola. Y square is equals to 4ax, right? This is rightward opening parabola. This is the focus a comma 0, vertex 0 comma 0, and we have a directrix x equals to minus a. So very important and beautiful concept is, if I have a focal chord, that means a chord which is passing through focus. If I know this is a focal chord, then these two are extremities of that focal chord. And from these 2 points, I can definitely draw a tangent, right? And the angle between these 2 tangents will be 90 degree. That is number 1. You need to remember, angle between these 2 tangents will be 90 degree. And second thing is, the intersection point of the tangent will be on your directrix. Yes, both the tangents will meet at the directrix. Okay, so I'm sure you must not be forgetting this concept. You should remember this concept. Let's get back to the question. Now we have a chord and we have a parabola. So basically this parabola, what kind of parabola is this, that we need to figure out. So basically this parabola is, if I actually rewrite this parabola as x minus 3 whole square plus y plus 4 whole square root is equals to what? Modulus 3x minus 4y minus 6 whole upon 5. That's it. Yeah, so this represents what? This represents PS is equals to PM, where PS is distance between moving point and fixed point, that is focus. So here moving point is x comma y and fixed point is, you gonna tell me what is a fixed point. Fixed point is 3 comma minus 4. This is focus, right? And what is the equation of directrix? Equation of directrix is what? 3x minus 4y minus 6 equals to 0, right? So these 2 informations we need to understand about this parabola, this type of parabola, right? That is automatically solved. Now, as per the concept which we have recalled just now, that any focal chord, but this is not a focal chord. Nobody has given us that this is the focal chord. So for that, we need to figure out whether it is a focal chord or any normal chord. Okay. So basically 3 comma minus 4 is the point which is focus. We need to satisfy this point in this chord. If I do that, what do I get? 3 to the 6 plus 12 minus 18. Okay, so this is a focal chord, right? So from the extremities of focal chord, we are drawing 2 tangents on this parabola, and we need to figure out the angle between tangents. Do I need to tell you that angle is nothing but option B, 90 degree? And in fact, moreover, I know one more information. Both tangent will meet at directrix at this point, right? 3x minus 4y minus 6 equals to 0. Both tangent will meet at this particular line. So this is all the question about. Okay, now is the time to write everything down very, very nicely. So this is parabola, this is chord. Coordinate of focus 3 comma minus 4. We have already calculated by this. 3 comma minus 4 is the coordinates of the focus, and equation of directrix is 3x minus 4y minus 6 equals to 0. And we all know that this chord which is given in the question is passing through focus, so it is a focal chord. And we all know that tangents drawn at extremities of focal chord are perpendicular. That means answer is 90 degree. But one more information for you guys, intersect at directrix, right? So final answer of this particular question is option B, 90 degree. This is my favorite question. In this question, we need to figure out the point on this parabola which is closest to this line. Let's just try to understand the situation roughly. Let me take any parabola, let's say y square is equals to 4ax, rightward opening parabola, and we have a line corresponding to that. And since point on the parabola being closest to this line, that means the distance, this distance would be what? Shortest distance, right? This is the point P, let us say, corresponding to this situation. And this distance would be what? Shortest, because we are looking for closest point, right? Whenever you need to know the shortest distance, always remember shortest distance lies on the common normal of both the curves. Yes, shortest distance lies on the common normal of both the curves. Okay, cool. So what I'll be doing is I'll be calculating the slope of normal to this line, which is what? Tell me, slope of this line is 3 and slope of normal to this line, that means slope of line which is perpendicular to this line, is nothing but minus 1 by 3. Right? Okay, so minus 1 by 3 is the slope of normal to this line. And now I need to compare this minus 1 by 3 with the slope of normal to this particular parabola. Isn't it? How to get the slope of normal to this parabola? By differentiating this curve with respect to x and calculating the value of dy by dx. Right? Once I know the value of dy by dx, so geometrically represent what? Slope of tangent. And if I know slope of tangent, negative reciprocal of that slope will represent what? Negative reciprocal of that slope will represent slope of the normal. Right? I just need to equate this minus 1 by 3 with the negative reciprocal of dy by dx and get the value of that particular point or coordinate on parabola. Let's begin. Now you know the algorithm. This is the parabola, this is the line. Now we know that m equals to 3. Right? M equals to 3. So slope of normal is what? With respect to the slope of normal is minus 1 by 3. Right? Now we are going to find slope of normal with respect to the curve. So differentiating the curve with respect to x, I'll be getting what? dy by dx is equals to what? 2x plus 7, which geometrically represents slope of tangent to the curve y equals to fx. But what I want is slope of tangent, isn't it? So minus 1 by 2x plus 7, that means negative reciprocal of this will be what? Slope of normal, that is equals to minus 1 by 3, which means that 2x plus 7 equals to 3. Okay. This implies that x equals to minus 2. Right? X equals to minus 2 is the point which is on the parabola. Right? Okay. If x equals to minus 2, I need y coordinate on the parabola. Right? And that coordinate will pass through parabola. That means x equals to minus 2 will satisfy the curve. We get y equals to minus 8. So minus 2 comma minus 8 being the point. Okay, this is the final answer. One more thing you can think about is about the situation that if this is a parabola, this is the line and you're looking for the common normal, what you can do is you can draw a tangent which is parallel to the line. And slope of this line and tangent would be equal. This is also the same logic, right? So for that, you need to equate 3 with what? Slope of tangent. So you'll get what? 2x plus 7 equals to 3. That means this directly you can get, right? So the concept behind this particular scenario is same. First, you'll think about the normal and then you'll think, okay, perpendicular to normal, what we are going to get? Tangent. So why not compare tangent directly? So behind that, you need to understand the logic is coming from normal only, right? So for this, minus 2 comma minus 8 is correct. Option D is right. In this question, we need to figure out the length of normal chord of the parabola y square is equals to 4x, which subtends an angle of 90 degree at the vertex. Okay. So basically this being your parabola and normal at point P is there such that this cuts the parabola at another point Q, PQ being your chord, normal chord at P, and this chord subtend 90 degree at the vertex. That means this angle POQ is what? 90 degree. Okay, cool. So basically there are 2 points involved. We need to apply mathematical condition for these two geometrical condition. The very first geometrical condition is normal at point P meets the curve again at point Q. That is number 1 condition. Number 2 condition is angle POQ is what? 90 degree. Angle POQ is what? 90 degree. Okay, let's begin. Let's compare it with standard parabola y square is equals to 4ax, a equals to 1, and we all know what is the condition of normal at point P. Let's say T1 meets the curve again at T2. The condition is this extremely important condition. T2 is equals to minus T1 minus 2 by T1. Here T1 is the point of normal. Please don't forget this. You cannot interchange T1 and T2. T1 is the point of normal. Q is the point which is T2, which is any other point from which that normal is passing, right? Okay. But the normal is at T1 and T2 is equals to minus T1 minus 2 by T1. This is the condition, right? Now, at this particular curve, point P would be what? AT1 square comma 2AT1. So T1 square comma 2AT1 and cube would be what? T2 square comma 2AT2. Right? A is already 1. So 2T1 would be there and 2T2 would be there. These are the 2 points. You know the coordinates of point P. You know the coordinates of point Q. You know the coordinates of point O. And you know that OP is perpendicular to OQ. That means slope of OP multiplies slope of OQ is what? Minus 1. M1, M2 minus 1. So we just need to calculate slope of OP first. Right? How to calculate? Y2 minus y1 whole upon x2 minus x1. This is 0 comma 0. This is what? 2t square comma 2t1. So 2t1 minus 0 upon t1 square, that is equals to what? 2 by t1. This is the slope of OP. 2 by t1. And similarly, slope of OQ is 2 by t2. M1, M2 equals to minus 1. That means t1 multiplied t2 is what? Minus 1. Sorry, t1 multiplied t2 is what? Minus 4. Whenever you see that two chords are perpendicular, always you will get this. T1, T2 equals to minus 4. And we have another relation between T1 and T2, which is what? T2 is equals to minus T1 minus 2 by T1. And T1, T2 equals to minus 4. This is equation number 1. This is equation number 2. If you solve this, you will get what? T1 and T2. Right? Let's solve this. So T2 would be what? Minus 4 by T1. So let's replace T2 by minus 4 by T1. Right? Now let's cancel out these 3 terms, these minus signs. So I'll be getting what? Okay. So I'll be getting 2 by T1 equals to T1. This implies T1 square is equals to 2. So T1 is either root 2 or minus root 2. Right? T1 is either root 2 or minus root 2. Similarly, T2 would be what? Tell me. If you put the value of T1 over here, what would you get? Minus 4 by root 2 and 4 by root 2. Right? And if you rationalize this, you'll get what? Minus 2 root 2, comma 2 root 2. So when T1 is root 2, you'll get T2 as this. When T1 is minus root 2, you'll get T2 as this. And you know A T1 square, okay, A is 1. So T1 square, comma 2T1 are the coordinates of point P. Let's substitute those values. Let's substitute this. So point P will be what? Root 2 square, comma minus, comma root 2 square, comma 2 root 2. So that means 2 comma 2 root 2 will be one of the points P, right? And P also can be what? Tell me. Minus root 2 square, comma minus 2 root 2. These could be your point P. So this is what? Tell me. 2 comma 2 root 2 and 2 comma minus 2 root 2. P either is what? 2 comma 2 root 2 or 2 comma minus 2 root 2, just like this. 2 comma 2 root 2 and 2 comma minus 2 root 2. Similarly, if you say that T2 is minus 2 root 2, then what will happen? So T2 square comma 2T2 will be there. And if you substitute T2 equals to minus 2 root 2, what would you get? 8 comma minus 4 root 2. And if you substitute T2 equals to 2 root 2, what would you get? 8 comma 4 root 2. So coordinates of Q would be this. Now you are interested in length of PQ. So for that we need to substitute the values in distance formula. So if you calculate PQ for both the scenario, for both the sets, length of PQ would be same, which will be equal to what? This. This is what? Square root of 6 square plus 6 root 2 whole square. And if you solve this, you'll get PQ equals to 6 root 3 units, which is exactly matching with option A. In this question, we need to figure out the set of points on the axis of this parabola from which all the 3 normals to the parabola are real. So basically, as we can see the options over here, the y coordinate of the option is very specific. And it is given that the points are lying on the axis of parabola. So first of all, we need to understand what is the axis of this parabola. Let's begin. This is the parabola, and if I make perfect square out of it, I'll get y minus 1 whole square minus 1 equals to 4x minus 5. Okay, plus 1 on the right hand side. So 4 times x minus 1 on the right hand side. Y minus 1 whole square is equals to 4 times x minus 1. So your parabola will look like this. So basically the vertex of this parabola is what? 1 comma 1. Let's try to draw the parabola. 1 comma 1 is the vertex, right? And this parabola is of the form y square is equals to 4ax. So this parabola is rightward opening parabola. So this is the parabola, right? And the axis of parabola will pass through vertex. So this is the axis. Okay, basically in y square is equals to 4x, the axis of parabola is nothing but y equals to 0, right? So that means in here y equals to 1 would be your axis of parabola. Okay, this is y equals to 1. So at this line y coordinate will be always 1. So if you need to take any point on this axis, what will you do? H comma 1, right? Y coordinate will be 1, x coordinate will be variable, so h comma 1 would be that. And on this axis we need to take one point such that from this point if I draw three normals, from this point if I draw three normals, all the three normals would be real, right? Okay, let's write down the equation of one such normal. Equation of one such normal in slope form of parabola y square is equals to 4ax is this, which is what? Y equals to mx minus 2am minus am cube. Now this normal is passing through one fixed point, isn't it, which is lying on the axis of the parabola. That means h comma 1 will satisfy this particular normal equation, right? Okay, so let's first write the equation of normal to this parabola. Let's write down. Okay, so equation of normal would be what? Y equals to mx minus 2am minus am cube. I just need to substitute the value of capital Y in small y terms, the value of capital X in small x terms, and the value of a. Okay, so this, if you compare these two, you'll get y equals to y minus 1, x equals to x minus 1, a equals to 1, because 4 is equals to what? 4a, a will be 1. Let's put the respective values over here. So that would be what? Y minus 1 equals to m x minus 1 minus 2m, a is 1, right? Minus m cube. This is your equation of normal. Let's just satisfy h comma 1 in this normal, because all the normal will pass through h comma 1 point, right, which is lying on the axis of the parabola. Let's do that. H comma 1. Okay, so if I satisfy 1 in the place of y, this will be 0, this will be h, right? So 0 equals to m times h minus 1 minus 2m minus m cube is your final equation. Now what to do about this equation? What we want is, in h comma 1, what I want is the range of h, right? Range of h I want, because I want set of points on the axis from which normal is real. Okay, normal is real. Okay, this is a cubic in m, isn't it? And if I carefully observe, m equals to 0 is one of the roots of this particular cubic. Hence, I am left with a quadratic. M equals to 0 and a quadratic. M square is equals to h minus 3. Now, all the normals being real, that means slope would be real. Okay, so m square, any squared quantity should be what? Non-negative. So, h minus 3 being non-negative, here comes the range of h, right? So, here h minus 3 greater than or equals to 0 for all real values of m. Hence, if I consider any point x comma 1 on the axis of the parabola, x would be greater than or equals to 3, and of course on the axis y is always 1. So clear cut, option A is right. Got it? In this question, it is given that a circle with radius r touches this parabola at 2 points such that area formed by common tangents and common chord is 32 square units, and we are looking for radius of the circle. Okay, so the question is all about first. So 50% question is all about the sketching correct figure. So this is rightward opening parabola, right? And since in the question it is given that there is a circle which touches the parabola at two distinct points, for this condition to be true, the circle should be symmetric about axis of the parabola, and the circle will look like this. If this is not symmetric, then the circle will exactly not touch the parabola at two distinct points. Okay, sorted. Now let's plot the common tangents given in the question. Common tangents, first common tangent, second common tangent, right? Tangents would also be symmetric about x-axis. Let's draw chord, common chord of the circle. So here is the common chord, right? How to draw the common chord? By joining point of contacts of the common tangent. So here is the common chord, and this area is what? 32 square units it is given to us. Let's now plot everything nicely. This is your figure, right? And ABC, area of triangle ABC, let's mark this point as D. Area of triangle ABC is 32 and we are looking for radius of the circle. Let's assume C1 is the center of the circle. Cool, sorted. Okay, since circle is symmetric about x-axis, so center of the circle will lie on x-axis. Okay, so if I compare this with standard parabola y square is equals to 4x, you'll realize that a equals to 1. And we've already discussed that for a circle to touch a parabola at two distinct points, the circle should be symmetric about the axis of the parabola, right? So here if I take point B, any point on this parabola can be taken as, or let's say this 80 square comma 280, right? Here A being 1, so B would be what? 80 t square comma 2t. Now we need to take mirror image about x-axis of point B to get point C, isn't it? Because B and C are symmetric about x-axis. So this would be what? T square comma minus 2t. B, C is sorted. Okay. What about point D? Basically, B and C are symmetric about x-axis. So point on this particular line x-axis would be D, which is midpoint of B and C. If you calculate midpoint of B and C, what would you get as coordinate of D, which is t square comma 0. So here you have B, C and D. B, C and D you have. What about point A? Point A is the intersection point of tangent, and we all know that intersection point will lie on axis of the parabola, isn't it? Because everything is symmetric about x-axis, right? So you know how to write the equation of the tangent to this parabola. Ty is equals to x plus at square, here a being 1. So ty is equals to x plus t square. At this point I'm trying to write the tangent, right? And you already know that on x-axis y is 0, right? To get this point we need to put y equals to 0. This will be gone, so x will be what? Minus t square. So minus t square. At this point I'm trying to write the equation of tangent, and putting y equals to 0 will give me x coordinate. So now you have A as well. Tangents and B and C intersect at A, which is minus t square comma 0. You have A, B, D, C. Now here comes the interesting part. If I talk about this particular triangle, which is ABD, since everything is symmetric about x-axis, this triangle has area which is equals to triangle ADB, right? So to get the triangle area of triangle ABC, I need to double the area of this triangle ABD. Let's talk about how to get the area of triangle ABD now. Now can you see this triangle has this angle 90 degree? So this is a right angle triangle, isn't it? This is a right angle triangle, and half into BD into AD will give you area of this triangle, and if you multiply it by 2, you'll get what? Area of triangle ABC. Now, what is DB? DB is this length, right? This length. So here coordinates you all know. This is t square comma 2t. This is t square comma 0. Distance between these two is what? 2t. So DB will be replaced by 2t. What about AD? AD. AD is this length, right? So minus t square comma 0, t square comma 0 will have distance between them equals to 2t square. Isn't it? This 2 is gone. So 4t cube is equal to what? 32. 4 8s are 32. T cube being equal to 8, that means t is equals to 2. From here you can easily say t is equal to what? 2. Isn't it? Okay, if t is equals to 2, but let's not forget what are we looking for. This is point D, this is point C1, and C1 is lying on x-axis. We are actually looking for radius of the circle. You know the coordinates of point B, which is t square comma 2t. In fact, you know the value of t now. Can you put the value of t to get the point B? Yes. So 4 comma 4, if you t square comma 2t, if you put the value of 2t is equals to 4, you will get what? 4 comma 4. So B is 4 comma 4. Point C1 is something comma 0. I just want that something. I'll apply distance formula and get the value of radius of the circle R. How to get it? Okay. So basically, AB line is a common tangent to parabola and circle, right? If I try to draw normal to this parabola, that normal will pass through C1, isn't it? Because that normal will be normal to circle as well, right? If there is a common tangent, definitely there will be a common normal, isn't it? Okay, so basically normal to the circle passes through the center. So what we are going to do, we are going to write the equation of normal at B to the parabola. And what is the equation of normal in parametric form? This. Y plus xt is equals to 280 plus 80 cube. Now we just need to plug the value of t in here and get the equation of normal. Okay, and that normal will pass through x comma 0, which being center C1 of the circle, right? Okay, if t is equals to 2, a equals to 1, our equation of normal would be what? Y plus 2x equals to, okay, 4 2's are 4 plus this is 80 cube, so this is 8. So y plus 2x is equals to 12 is your equation of common normal. Now this is equation of parabola. Now satisfy x comma 0 in this, right? So if y is 0, x will be what? 6. So this would be what? 6 comma 0. Center of the circle is 6 comma 0, isn't it? Center is 6 comma 0. So point C1 is what? 6 comma 0. And point B is what? 4 comma 4. We just need this distance BC1 to get the final answer of this particular question. Let's do that. So 6 comma 0 4 comma 4, that is square root of 6 minus 4 whole square plus 4 minus 0 whole square. This is what? 2 root 5 units. Yes. So final answer of this particular question is 2 root 5 units. Got it?